In this lesson, we're going to discuss fundamental counting principles. Fundamental Counting Principles, or FCP, states that if activity A can be done in n sub 1 ways, activity B can be done in n sub 2 ways, activity C in n sub 3 ways, and so on, then the activities A, B, and C can be done simultaneously in n sub 1 times n sub 2 times n sub 3 and so on ways. So, ibig sabihin, kailangan mo lang i-identify kung ilang ways ang bawat independent event sa isang situation, and then multiply mo lang lahat yon para malaman mo kung ilang total number of possible ways can it be done simultaneously. Yun ang ibig sabihin ng ating fundamental counting principles. Let's try to have this problem. A close friend invited Marie on her birthday party. Marie has 4 new dresses, sleeveless, stripes, long sleeve, and with ruffles, and 3 shoes, black, pink, and blue, in her closet reserved for such occasions. In how many ways can Marie select her outfit if any shoe can be paired with any dress? So first, before we use the fundamental counting principles, pakita muna natin siya using tree diagram. Let's say, gagamit siya ng sleeveless na dress. So, pwede siyang i-pair sa black shoes, sa pink shoes, at sa blue shoes. So, we have 3 pairs pagdating sa sleeveless. Sa stripes dress naman, pwede siyang i-pair sa black shoes, sa pink shoes, or sa blue shoes. So, another 3 pairs. Sa long sleeve naman, pwede siya i-pair sa black shoes, sa pink shoes, at sa blue shoes. So, another 3 pairs. Pagdating sa ruffled or with ruffles na dress, pwede siyang i-pair sa black shoes, sa pink shoes, at sa blue shoes. So, another 3 pairs. So, all in all, we have 12 ways to select kung anong outfit ang gusto ni Marie. Using fundamental counting principles, kailangan nating i-identify kung ilang beses siya pwedeng mamili ng dress or ilang beses siyang pwedeng mamili ng sapatos. And then, multiply lang natin yan, then that will be equal to 12 possible pairs. So, using tree diagram or using fundamental counting principles, we can be able to solve na 12 possible pairs yung pwedeng gamitin ni Marie sa pag-attend ng birthday party. Let's try another problem. A person wants to buy 1 fountain pen, 1 ball pen, and 1 pencil from a stationery shop. If there are 10 fountain pen varieties, 12 ball pen varieties, and 5 pencil varieties, in how many ways can he select these articles? So, using fundamental counting principles, i-identify natin kung ilang beses siya pwedeng mamili ng fountain pen, ng ball pen, at saka ng pencil. So, from the problem, pwede siya mamili ng 10 fountain pen. Sa ball pen naman, 12 ways para makapili, at sa pencil, 5 ways. So, multiply lang natin lahat yung independent event na yan, and then that will be equal to 600 ways. So, 600 ways siya pwedeng makapili ng kanyang mga bibilin from a stationery shop. Next problem. You are choosing a password that has 4 letters followed by 2 digits. How many passwords are possible if letters and digits can be repeated? So, using fundamental counting principles, we have 4 slot para makapili ng mga letters at saka 4 slot para makapili ng digits. But take note, letters and digits can be repeated. So, pwedeng maulit. So, ilan nga ba yung pwede natin ilagay na letters from to the first slot? So, pili tayo starting from letter A to Z. Ilang letters yon? Those are 26 letters. So, sa first slot, 26 letters ang pwede. Same with the second, sa third, and sa fourth slot. Kasi nga, digits and letters can be repeated. So, ibig sabihin, pagdating sa slot ng digits, 0 to 9, we have 10 choices. And same with the second digit, 10 choices pa din. So, multiply lang natin sila lahat, then that will be equal to 45,697,600 ways to choose a password. Same problem a while ago, but this time, digits cannot be repeated. So, from the fundamental counting principles, again, we have 4 slots for the letters and 2 slots for the digits. Pero dahil digits cannot be repeated, so bawal maulit yung mga digits, same with the letters, magbabawas tayo ng mga choices per slot. So, A to Z, ang first slot natin is 26. So, pag nalagay mo na yung isang letter, bawas ka na ng isang choice, that is 25. Then, 24 and 23. Pagdating sa digits naman, we have 0 to 9. So, sa first slot, 10 choices pa rin. Pero pagdating sa second slot, bawas na yung pagpipilian natin. So, multiply lang natin sila lahat. Then, that will be equal to 32,292,000 ways. Tayo pwedeng mag-create ng 4-lettered followed by 2-digit password. And take note, digits cannot be repeated. So, distinct ito. Next problem, to buy a computer system, a customer can choose one of 4 monitors, one of 2 keyboards, one of 4 computers, and one of 3 printers. Determine the number of possible systems that a customer can choose from. So, using FCP, meron tayong iba't ibang independent events. Una, yung pagpili ng kanyang monitor. Pangalawa, yung pagpili ng keyboard. Pangatlo, yung pagpili ng computer. At pang-apat, yung pagpili ng printer. So, ilang beses siya pwedeng mamili ng monitor? We have 4 ways. Sa pagpili ng keyboard, we have 2 ways. Sa pagpili ng computer, we have 4 ways. At sa pagpili ng printer, we have 3 ways. So, using fundamental counting principles, i-multiply lang natin lahat ng independent events na yan. 4 times 2 times 4 times 3, that is equal to 96 ways. So, 96 ways siya pwedeng mamili ng kanyang arrangement of systems, computer systems. Next problem, a student can select one of 6 different mathematics books, one of 3 different chemistry books, and one of 4 different science books. In how many different ways can a student select a book of mathematics, a book of chemistry, and a book of science? So, using FCP, meron tayong 3 events. Una, yung pagpili ng math book. Pangalawa, yung chem book. At pangatlo ay yung science book. So, ilang beses siya pwedeng mamili ng math book? Pwede siya mamili ng 6 math books. Pagpili ng chem book, 3 ways. At pagpili ng science book ay 4 ways. So, multiply lang natin sila lahat. 6 times 3 times 4, that is equal to 72 ways siya pwedeng mamili ng math book, chem book, at ng chemistry book. Next problem. There are 3 different roads from CTA to CTB and 2 different roads from CTB to CTC. In how many ways can someone go from CTA to CTC by passing CTB? So, ibig sabihin sa problem na to, kailangan alamin natin kung ilang ways ka pwedeng dumaan or pumunta from CTA to CTC pero kailangan dadaan ka sa CTB. So, it means CTA going to CTB, going to CTC. So, first, identify muna natin yung mga independent events. So, una, CTA to CTB, ilang ways yon. Tapos, CTB to CTC, ilang ways yon. So, CTA to CTB, we have 3 ways. CTB to CTC, we have 2 ways. So, multiply lang yan. It means we have 6 ways to go from CTA to CTC passing by CTB. Next problem, in a company, ID cards have 5 digits numbers. How many ID cards can be formed if repetition of the digits is allowed? So, using FCP, we have 5 ways to choose for the digit. Kasi 5-digit number, so we have 5 slots here. And since repetition of digit is allowed, pwedeng maulit yung mga digits. So from 0 to 9, meron tayong 10 choices para sa first digit, another 10 choices sa second, 10 choices sa third, same with the fourth, and same with the fifth. Kasi nga repetition of digit is allowed. So multiply lang natin silang lahat, and that will be equal to 100,000 ways to create a ID cards that have 5-digit numbers. Next problem, using the digits 1, 2, 3, and 5, how many 4-digit numbers can be formed if the first digit must be 1 and repetition of the digits is allowed? So meron tayong ilang conditions na dapat i-consider sa pag-solve ng problem na to. So using FCP, we have 4 slot kasi nga 4-digit numbers yung kailangan nating isolve. Pero yung first digit natin must be 1, so isa lang dapat na choice yung pwede nating ilagay sa unang slot kasi 1 lang daw ang pwedeng ilagay dito from 1, 2, 3, and 5. So ilan lang yung choices natin? We have 4 choices. Pagdating sa second digit, dahil repetition of digits is allowed, tapos 4 lang naman yung choices natin, so ibig sabihin we have 4 dun sa second slot. Pagdating sa third slot, 4 pa din kasi repetition of digits is allowed, and last is 4 pa rin kasi we can have 1, 2, 3 at saka 4. 4 digits lang yung pwede nating ilagay. And since fundamental counting principles, i-multiply lang natin lahat yan, so that will be equal to 64 ways. Next, the same problem a while ago, but this time repetition of digits is not allowed. So bawal maulit yung mga digits. Pero yung 1 pa rin dapat yung nauna dun sa ating arrangement. So again, 4 slot pa rin yung pwede nating gawin kasi 4-digit numbers. Tapos yung first digit must be 1. So 1 lang daw yung pwedeng ilagay sa unang slot. So isang choice lang yon. And then sa second slot, dahil nakalagay na yung 1, 3 na lang yung pagpipilian natin, yung 2, yung 3, tsaka 5. So 3 na lang yung po pwede nating ilagay sa second slot. Pagdating sa third slot, dahil nakalagay na yung dalawang numbers sa first slot tsaka sa second slot, 2 na lang yung pagpipilian natin, at sa last digit, 1 na lang yung pagpipilian natin. So multiply lang natin sila lahat, 3. We have 1 times 3 times 2 times 1, that is equal to 6 ways. So 6 ways lang natin siyang pwedeng makakreate ng 4-digit numbers following those conditions. Let's try to have this problem. Using the digits 1, 2, 3, and 5, how many 4-digit numbers can be formed if the numbers must be divisible by 2 and repetition is allowed? So using fundamental counting principles, dahil 4-digit number, meron tayong 4 na slot para sa ating digits. So first, kailangan natin ilagay yung last digit dahil divisible by 2 daw siya. So para masabing divisible by 2, dapat nag-i-end sa even number or sa 0, 2, 4, 6, 8 yung last digit. So since 2 lang yung pwede nating ilagay dun sa last slot, it means meron lang tayong 1 choice. 2 lang ang pwedeng ilagay dito. And repetition is allowed from 1, 2, 3, and 5. 4 choices lang tayo, tapos repetition is allowed. So, sa unang digit, meron kang 4 choices kasi 1, 2, 3, at saka 4. And then, sa second slot, 4 pa din at sa third slot kasi nga repetition is allowed. So, multiply lang natin lahat yan. 4 times 4 times 4 times 1, that is equal to 64 ways. So, kailangan i-check nyo yung bawat conditions. Let's have our next problem. A coin is tossed 3 times. So, isang coin lang yan. What is the total number of all possible outcomes? So, 3 times tayo magtotoss ng coin. So, meron tayo dito, let's say, piso. Sa unang toss, meron kang head or tail na pwedeng lumabas. So, dalawa yung outcome na pwedeng lumabas sa first toss. Sa second toss, kapag head yung unang lumabas, sa first toss, meron kang head and tail sa second toss. Kapag tail naman yung unang lumabas sa first toss, meron ka ring head or tail na pwedeng lumabas. Pagdating sa third toss, kapag head-head ang unang lumabas sa first and second toss, pagdating sa third toss, meron kang head and tail pa rin. Same kapag tail yung lumabas, head and tail pa rin. So, following the process, ganyan yung magiging tree diagram natin. So, ibig sabihin, yung unang possible outcome natin is head, head, head. Head yung first toss, second toss is another head, and third toss is head ulit. Or head, head, tail. Ang pinagkaiba lang, yung third toss ay naging tail na. Or head, tail, head. Next, head, tail, tail. Next, tail, head, head. Next, tail, head, tail. Next, tail, tail, head. And the last is tail, tail, tail. So, over and all, we have 8 possible outcomes. So, check natin using fundamental counting principles. So, ilang possible ways ba pwedeng nagkaroon sa unang toss, sa second toss, at saka sa third toss? So, sa unang toss, ang possible outcome is dalawa, yung head or tail. Sa pangalawang toss, head or tail pa rin. Sa pangatlong toss, head or tail pa rin. So, i-times lang natin lahat yung events na yan, and then that will be equal to 8 ways. Ito nga yung mga ways or yung possible arrangement na pwedeng lumabas kapag ang coin ay matotoss siya 3 times. Next problem, 2 dice are rolled. So, dalawang dice. What is the total number of all possible outcomes? So, 2 dice daw yung kanyang i-roll. So, using fundamental counting principles, yung unang die, ilan ba yung possible outcome? Same with the second die. So, sa unang die, meron kang 6 na outcome kasi 6 yung mukha ng isang dice. Die ang ginamit ko kasi singular siya. Pagdating sa second die, meron ka pa ring 6 na faces. So, 6 pa rin yung possible outcome. It means, i-multiply mo lang siya, and then that will be equal to 36 ways. So, 36 ways yung total number of possible outcomes na pwedeng lumabas kapag 2 dice are rolled.